Hello. So I've been requested a few times to do more things on probability than I have calculus. So I thought this question, it's moderately hard. It's not really that hard. It's just a standard complex, probably a complex question considering it's 4 marks, not like 2, 1, 3. But it's an alright question. And it takes a bit. This is tech active also, tech active. So you need your calculator. But it's a decent question. So bottles of soft drink should contain a volume with a mean of 591. So when I first saw volume, I was thinking it might be a volume question based on having to calculate between like area and volume, but obviously not. It's just a standard probability question. So a mean of 591 mils. So usually I just underline it. Mean equals 591 mils. Remember your units are important in case it asks for your final answer in liters or something. That would be just nasty, but it can happen. But some variation is expected. Yeah, normal distribution. Any bottle at or below the 20th percentile of the volume distribution is rejected. So that means, so 20th percentile, so if we have, I'm just going to draw this temporarily, so if we have a normal distribution curve, like this, it pretty much means that at the area, so pretty much 20th percentile is this z-score, or this point on the normal distribution graph. Let's just call it z and assume we're using the z distribution. So this would equal mu equals 0, whatnot. So that means that this point here, it's anything below this point is in the 20th percentile, because it's 0.2. The area behind this is 0.2 on the graph. It's just that area right there. So it's anything below the 20th percentile. I'll just erase that. That's just a quick explanation on percentile, in case you've forgotten. It is rejected. So that means that x is less than, so x is less than, and then the value that you're looking for. So let's just call it little x is equal to, so this is your rejected value, and that's equal to 0.2, because that's the area. Is rejected. So this is the rejection. I'll just write rejection under here. And percentiles, yeah, that doesn't really matter. 35% of bottles contained 593 mils or more. So 35%, which means that the P is going to be equal to, so it's going to be equal to 0.35, 35% of X, and what is it? Contain this or more. So 593 or more. So X is greater than 593 is equal to 0.35, which is equal to 35%. Just remember that. So, assuming that the volumes are normally distributed, determine the smallest volume in mils that will be accepted. So it's good that they're asking in mils, so we don't need to do any unit conversion. So, the first thing we'll need to do is, the easiest way to do this would to convert these values into z values. So your z values on your z curve, because it's just easier to work with. So let's go p x is greater than, capital Z is less than little z is equal to 0.2. And let's get a z-score for this. But also, let's just comment here, p big Z is greater than little z. So let's call this z1 and z2, but both these z's stay the same because this is signifying the z curve. Is equal to 0.35. So we'll get a value for both of these. So right in the middle, I'll write using inverse norm on GDC. You can kind of write it whatever way you want, as long as you signify that you're going to use a calculator to do it. So I'll do that now. So for z1, using inverse norm, we get z1 is equal to, this is going to be less than z, gives you 0.2, which is going to be equal to negative 0.8416. It's usually good to have a few decimal places when using probability, usually just because it's always 0 point most of the time. Yeah. And now z2 is equal to, I'll do that now. So 0.35. is going to be positive 0.3853. So these are both the z values. And you need to remember that your, let's go over here, z is equal to x minus mu over sigma. So if we go into here, we can go z1 equals x minus mu over sigma. And I'll zoom back in here. So using z1, we'll go negative 0. Actually, first let's use this side here, to try and determine what sigma is, because we already know mu from the question, but we don't know sigma, and we're going to need sigma to figure out the rest of the values. So let's just find all of our unknowns. So we have our x value, we have our sigma. Remember, our area, our mean, which is 591. So I'm just going to write this here, 591, from the question. So now we can go 0.3853 equals, so this is just from here, equals 593 minus 591 over sigma. Now let's go, so sigma is going to be equal to 2 over 0.3853, which is going to be equal to, calculator, 5.19. Sigma equals 5.19. 191, or I'll just leave it as 19. So sigma is equal to 5.19. So now that we know that value, that isn't our answer, but now that we know that, so we need to know what value for z. So we need to know what volume is rejected. Which is in the 20th percentile. So we have this formula, but we need to use our values to find it. Now because we know that z1 is equal to this over this, we have our, we don't have this value, but we have this value, and this value. So we can rearrange this equation in order to find x, because x is going to be the volume that sits in here, which is rejected, if that makes sense. So let's just put area, so I'll go z sigma equals x minus mu, and then x equals z sigma plus mu. X is equal to, so the z value from up here is negative 0.8416 multiplied by sigma, which is from here, is 5.19 plus 591, which is mu up here. So if we put that into the calculator, 0.814 times 5.19 plus 591, yeah, 586. If you wanted to evaluate the reasonableness of your solution, or it's actually 0.77, I'm sorry, so it's approximately equal to 587. So if you want to just quickly evaluate how reasonable your solution is, so it's the lower end of the scale that would get rejected. 587, you know, is lower than the mean, so it's a pretty reasonable answer, 587. So that is going to be milliliters. That's going to be your answer, 587 milliliters. So this is from the QCAA 2020 External Exam Paper 2, the Tech Active paper. I usually don't like doing tech active questions because I hate the pause as I'm punching numbers into a calculator, but yeah, I've been asked to do probability questions, so there's that. Now this is another one from the exact same paper. It's actually the question afterwards. Question 17, this one's question 16. There's also 4 marks. So this says, in a survey of 326 lecturers, 303 said that on at least one occasion, a mobile phone has rung in a lecture they were giving. Determine the sample size required to conduct a follow-up survey that provides a 95% confidence that this 1 point estimate is correct within 0.02 of the population proportion. so this 1 point estimate is correct within plus or minus 0.02. So that pretty much means that your confidence interval, because you know you have your this plus z theta, that minus z theta. So when you have this part here, because pretty much when you have delta p hat, so let's just draw a little number line here pretty much to just imagine this. We won't put values on the number line, but we'll just put, so here's p. So when you go p hat plus z theta, so you're pretty much going this way by z theta. And when you go minus z theta, you're pretty much going this way by z theta. So when you have your confidence interval, it's pretty much, so you're plussing it, so you're going out to here, and you're minusing it, so you're going out to here. And you pretty much end with a confidence interval that is within, so you could be 95%, for example, confident that it's within these boundaries, pretty much, right? So when it gives you a value like plus or minus 0.02, this is referring, because this could be written as delta p plus minus z theta. So it pretty much wants your z theta to be equal to 0.02. So now I'll rubble this stuff out. But I hope that makes sense, because your e value, which is equal to z theta, is a plus or minus value. Because theta is calculated with a square root. Square root of p1 minus p over n. So that's going to be a value which will give you a plus or minus answer, because all square roots end with a plus or minus answer, if that makes sense. So, so let's just underline that and go z sigma is equal to 0.02, or plus or minus. Okay, so that provides a 95% confidence interval. Now remember that a 95% confidence has a z that's equal to 2.58. So now, actually no, I lied. It's 1.96. Because it's so 90, 95, and 99 are 649658, so it's 2.1.1. So it's 1.96 for a 95% confidence interval. So now, z sigma is equal to 0.02. Let's just leave it like this, and let's just go z is equal to 1.96. Let's just synthesize all the information. And this is at least one occasion. So determine the sample size required. So the sample size is going to be your n. Sample size is equal to your n value. So now let's expand pretty much this, because these are the values that we know, and you know that you can put this value into here. So let's go 1.96 sigma, because we're just subbing this value in, is equal to 0.02. And now let's divide both sides by 1.96, because now we know this information. So 1.96, 0.02, sorry, just using calculator, divided by 1.96, it gives you, so sigma is equal to plus or minus, remember, 0.01, 0.0102. So that's your value. Now remember that, so I'm going to put this on the side of the, I'm just going to swap their sides of the equation, because this is quite a large thing when you expand it. So plus or minus 0.0102 is equal to, and now let's, so remember that sigma is equal to, or the standard deviation, is equal to the square root of p hat 1 minus p hat over n. And now, if you look at the side of the question, on a survey of 326 lecturers, 303 sat. So let's also, you know that your sample proportion, or p hat, is going to be equal to x over n, which is the amount of times that's occurred over the sample size, which is equal to 303 over 326, which is going to be equal to, let's use the calculator again, 326, 0.9294. 0.9294. That's your sample proportion. So let's sub this in, and after this we may have one unknown. So 0.0102 plus or minus is equal to 0.9294. 1 minus 0.9294 divided by n. And now we can just use algebra to figure out n. So now let's square both sides here. This is going to end up in scientific notation, so I'm just going to leave it in this form. So it's going to be plus or minus. It's no longer plus or minus, remember, because we're just squaring it. So that will just, because even if it's negative, it'll end up being positive anyway, because we're just timesing it by itself. So 0.0102 squared is equal to 0.9294, and then 1 minus that would be 0.0706 divided by n. So now we can swap these, as you know, just so n is equal to 0.9294, which is not touching calculator yet, 0706 divided by 0.0102 squared, and they can go n is equal to, so I'll just do this, 0.9294 times 0.0706 divided by 0.0102 to the second power 6. N is equal to 630.677, which is roughly, approximately 631. That'll be an answer. N is equal to 631. And because it gives you a scenario of how much of a proportion, how much of a sample size you'll need, just go overall the required sample. I don't really think this is in the question criteria for a high mark, like in the marking guide, but I'll just write it anyway just to make sure. Required sample size is 631 subjects. I don't know what's the word for it. Test. I don't know, people. That works. Okay. So yeah, these are two probability questions that were side by side. They're kind of different things. One of these use sample proportions. I mean, a confidence interval question. So yeah, that's a confidence interval kind of question. This is a normal distribution kind of question. And yeah, I wish you luck on the exam. Thank you for watching. Have a nice night or day.